Hey everyone. Last video we talked about pyramids. Today we're going to talk about cones. Cones are not polyhedrons, or polyhedra, I should say. What a cone is a three-dimensional figure with a circular base and a lateral surface that connects the circular base to a vertex off the base. Cones are one of the figures that I have the most trouble drawing, so please don't judge the quality of my drawing. But the base is a circle, so it's got a radius. And the perpendicular distance from the base to this vertex is the height. There are no lateral surfaces. There's just this smooth surface around. I'm sorry, there's no lateral faces. There's just this smooth surface around called the lateral surface. It is not a face because it's not a polygon. And this distance from the vertex to a point on your circular base is called your slant height. Just like the distance, the height of the triangular faces in the pyramid, we use that same terminology here. It is our slant height. So that is a cone. So the cone, it's composed of two surfaces, the base, the circular base, and this lateral surface. Most of our cones are going to be right cones like this one. A cone is a right cone if that height from the vertex to the circular base contains the center of the circle. If it doesn't contain the center of the circle, it's an oblique cone. We're not going to do much with oblique cones, but they do exist. You could have your circular base and then your vertex over here, such that the height is exterior. Now, just like with oblique pyramids, the slant heights are going to be different. So there's not going to be just a fixed slant height. So that's why we're going to work primarily with right cones and not oblique cones. So let's break down the two surfaces that make up the cone in order to have our make our net and then find the surface area. So I'm just going to do a really rough sketch of our cone. Here. Got our radius, got our height, got our slant height. So there's two surfaces. The first and easiest surface is the circular base. So that's our base. And then the other surface is that lateral surface. If we were to cut it along one edge and unroll it, well, it's really like a series of segments that are all the same length from that vertex. And that length is the slant height. And it's just a bunch of points that are that distance from that. So, this is the shape of our lateral surface. And that shape is a sector. That shape is a sector. One thing we know about that sector is we know the radius of the sector is the slant height, and the arc length of the sector would wrap around this circular base. It's 2 pi r. Now, if you think back to where we developed a really rough understanding of our area of a circle, we basically treated it like the area of a bunch of triangles getting smushed together. That's what we're going to do here as well. Our base area is just pi r squared. That's easy, it's the area of the circle. But our lateral area, it behaves like a triangle even though it isn't a triangle. It is the area of this if it were a triangle. So 1/2 times the base, which is 2 pi r, times the slant height. Very similar to the lateral area of a pyramid. The lateral area of a pyramid was 1/2 perimeter of the base times the slant height. It's very similar. Just our perimeter is now, we don't have to account like, oh, what's the number of sides, what type of figure is the base. The base is always going to be a circle. So it's 1/2 times 2. So the lateral area is pi r l. So this is how you find the surface area of a cone. The surface area of a cone, it's the lateral area plus the area of the base, and more simply, pi r l plus pi r squared. So that's the surface area of a cone. It was essentially, and I should put cone. It was essentially the same as the surface area of a pyramid. And that's how we're going to get the volume formula of a cone as well, from the volume formula of a pyramid. Cones are very similar to pyramids, just in the sense that the number of side lengths on the base is approaching infinity. That's how you can think about it conceptually. A cone is not a pyramid. I will restate that. A cone is not a pyramid, but it behaves similarly to a pyramid in the sense that we can get the same formulas to yield the same results. So the volume of a pyramid was 1/3 times the area of the base times the height. That is the same thing for the volume of a cone. But this time, there's not ambiguity as to what type of figure the base is. The base is always a circle. So it's 1/3 pi r squared times the height. So that's cones and pyramids. Have fun.